Hi friends, in this video, we had seen before going to explain about the contents of this video. So till now we had seen what is algorithm analysis, so how to analyze the algorithms, what are asymptotic notations big O, omega and theta, and now will see how to find time complexity for two different algorithms. One is binary search and second one is linear search. How to find the time complexity for linear search and binary search. So first we shall see how to find the time complexity for linear search. So linear search time complexity. The best example for linear search is, suppose in our home, if you have taken a set of n photos and you want to you want to search for a particular photo. So generally what we'll do, we'll select one by one. So first photo, second photo, third photo, fourth photo. That means you're going to search till your photo is found. So it can be found at first level, that means at first photo or middle photo or till nth photo. Sometimes we are unable to find the required photo. So that means we have in linear search will follow the same process. That means if we have an array with set of values like, so 10, 15, 20, 30, 9, 8, 7, 6, 5. Let us assume that an array with these many values are there. So first case, so that means success case. If I am searching for 10, it will be found at first position. That means after first iteration. If I am searching for 9, so 1, 2, 3, 4, 5, 1, 2, 3, 4 at fifth position. And similarly, if I am searching for 5, 5 is at 1, 2, 3, 4, 5, 6, 7, 8, 9, ninth position. If I am searching for 4, which is not at all there, not found. When will know the 4 is not available? So that means first we are searching for 4 is not equal to 10, 4 is not equal to 15, 4 is not equal to 20. That means this value is 20, 20 is not equal to 4, 30 is not equal to 4, 9 is not equal to 4, 8 is not equal to 4, 7 is not equal to 4, 6 is not equal to 4 and 5 is not equal to 4. I have searched all the elements of an array, but I found that means I found no element with the value of 4. In that case, not found. So that means we may get the value at first position. That means the time complexity can be order of 1. The time complexity can be n by 2 and the time complexity can be n. So that means in general we'll give importance to this value. Now how to find the time complexity? So instead of saying directly, so first of all I'll try to explain by writing the program for the linear search. So first, for linear search, what are the required elements that we need? We need an array of size n. So let us assume that int n equal to 9. And similarly, I'm going to declare an array of size 9 is equivalent to with the values of the same elements 10, 15, 20, 30, 20, 30, 9, 8, 7, 6, 5. Now I'm going to search for an element int x. So printf enter key scanf %d ampersand x. Now what I'm going to do, I'm going to start at first index. Here index will start at 0. Then I'll search till the last element I less than n, I plus plus. So if element is found, then I'll stop this process. So if given a, that means if x is equivalent to or a of I is equivalent to x, that means for what you are searching x, so if it is there at the ith index, then stop the process, else keep on iterating the process. Now see, if now finally what is the value of n after completion of this loop? N. So if I equal to n, then printf element not found, else printf element is found at I plus 1 position. Now for doing the analysis, so this statement will be executed for one time, 1 unit of time. This will be 1 unit of time because creation of array, and this will be 1 unit of time. So this will be 2 units of time, and this will be iterated based on the condition. That means it may be iterated for n times or it may be iterated for one time. That means it can be iterated in best time. In case of best, it will be one time. So in case of average, it will be n by 2 times. In case of worst, it will be iterated for n plus 1 times. So that means the if condition will be checked either for one time, or it can be checked for n by 2 times, or it can be checked for n times. Now, so this condition will be checked only once, and if this is true, then it will be executed, or else this will be executed. That means either this or this will be executed. So if it is n plus 1, if it is executed for n plus 1 times, then this will be executed, and if it is executed for less than n times, less than n plus 1 times, then it will be executed. That means this block will be 2 units of time. Either of this is getting executed. So now see, the time complexity in best case is 1 plus 1 plus 1 plus 2 plus 1 plus 1. So 3 to 5, 5 to 7, 7 and 3, 10. That means the time complexity in best case and worst case, 10 in best case, and in worst case n by 2 plus n by 2. N by 2 plus n by 2 is nothing but n by 2 plus n by 2, which is equivalent to n, because n by 2 plus n by 2, which is equivalent to 2n by 2. So which is n. So now that means in average case, how many times it will get executed? So 3 to 5, 5 n plus 8. In worst case, it will be executed for 3 to 5, 6, 9 and 2n plus 9. So finally, in constant time can be represented as order of 1, and n plus 8 can be represented as order of n. 2n plus 9 can be represented as order of n. That means in best case it is order of 1, in average and worst case it will be order of n. So that is the time complexity of linear search. So we cannot assume the best case inputs all the time. So we have to assume the inputs either average, most of the times it will be worst case. That means element is not found or element is available at the last location. So these kind of things. So now the time complexity of the linear search is order of n. according to the previous state that we had seen. So this is upper bound. Now we are finding the upper bound because there is no tight bound here. Tight bound in the sense we cannot assume that it is n plus 8 all the time because this is average value. So most of the time we are assuming that it is 2n plus 9. So sometimes it can be n plus 8, sometimes it can be found at 1. So all the time, so finally we can say that the time complexity of average time complexity of the algorithm is order of n. So now we had seen that, but how this algorithm gets executed? So initial value of I is 0. So a of I is what are the values of a of I? 10, 15, 20, 30. So that means an array with the values of 10, 15, 10, 15, 20, 30, 9, 8, 7, 6, 5. 9, 8, 7, 6, 5. Now this is 0, 1, 2, 3, 4, 5, 6, 7, 8 indexes. So a of I is equivalent to 10. We are searching for, let us assume that we are searching for 4. So I equal to 0 and 0 is less than n value is 9, condition is true, then 10 is not equal to 4, then I value is incremented by 1, that is 15, 15 is not equal to 4, then I value is 2, 2 is less than 9, then value is 20, 20 is not equal to 4, I value is 3, then this is 30, 30 is not equal to 4, I value is 4, that is 9, 9 is not equal to 4, and I value is 5, that is 8, 8 is not equal to 4, I value is 6, this is 7, 7 is not equal to 4, I value is 7, this is 6, 6 is not equal to 4, I value is 8, this is 5, 5 is not equal to 4. Whenever I value is 9, 9 less than 9 condition is false. So I am coming out of the loop. So where I value is 9, 9 equal to 9. That means if n value is given as 9, then this loop is getting repeated for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 10 times, which is nothing but n plus 1 times. So based on this one, I have found the time complexity mentioned above. So now we shall type the same program, program in the code, that is code blocks. So I am taking n value as some 20, then int main. So before that I am going to create declare hash include. So hash include stdio.h, then int main return 0 and int a of is equivalent to let it be, I am declaring int a of n. So I am going to search for an element int x, I is the index of an array, then printf enter. I am going to read the n value also. I am declaring it as max. Max is some 200 elements. Int a of max. So then I am taking n value. So enter size of array. Scanf percentage d ampersand n. So then printf enter array values, then for I equal to 0, I less than n, I plus plus, then reading the values for n. So scanf, sorry, a of I, scanf percentage d, a of I, then printf, enter key, scanf percentage d ampersand key. That means we are going to search for a particular key, that is x. Then for I equal to 0, I less than n, I plus plus, if x equal to a of I, then break, if I equal to n, then printf element is not found, else printf backslash n element is found at percentage d position I plus 1. So then now I am executing this program, control F9. So one error is there, scanf percentage d ampersand n, scanf, so this one semicolon is not there, control F9, control F10. So enter size of an array. So I am taking 9 elements, 10, 15, 20, 30, 7, 6, 8, 5, 9. So 9 elements I had taken. How many enter array values? 9 elements have been taken. Yeah, process return, that is a problem with the program, the compiler, no issues. Enter key to find, sorry, control F10, enter size of an array 9, enter array values 10. What happened? So sorry, I had to give ampersand, otherwise it will give an error. So note down the errors that I am identifying while typing a program. So 9, 10, 15, 20, 30, 7, 6, 9, 8, 5. Enter key value I am giving it as 10 first. Element is found at 10th position, and I am executing it the same program. 9, 10, 20, 15, sorry, 10, 15, 20, 30, 7, 6, 9, 8, 5. I am searching for 5. 5 is found at 9th position. Then fine. I am giving the same array. So 10, 15, 20, 30, 7, 6, 9, 8, 5. I am going to search for 4. 4 is not found. So the time complexity is also, I have explained how to compute the time complexity for linear search. So now the time complexity for the linear search is order of n. Now time complexity for another algorithm. Is there an algorithm which can reduce the time? That is binary search. So how to do the same thing in binary search? So our values of an array are, I am taking the same array. So 10, 15, 20, 30, 7, 6, 9, 8, 5. So the first condition of binary search is elements should be in sorted order. So that means my elements should be 5, 6, 7, 8, 9, 10, 15, 20, 30. Now keep the elements. I am keeping the elements in the process of array, in the box of array. So 5, 6, 7, 8, 9, 10, 15, 20, 30. This is 0th index, this is 8th index, 1, 2, 3, 4, this is 4th index. Let us assume that. Now how binary search will work? So there are 3 cases. Case 1, I am going to search for 6. Case 2, I am going to search for 20. Case 3, I am going to search for 9. Case 4 cases. Case 4, element not found, that is x equal to 4. There are 4 cases. Now in first case, what it will do? So now in binary search it will take 2 variables. One is low, that is equivalent to 0, and second one is high, that is equivalent to ending index, that is 8. Then what it will do is it will find the mid value. Mid value is equivalent to low plus high by 2, that is equivalent to 4. Now the fourth position value is 9, which is not equivalent to 6, but 6 is less than to 9. Since it is in sorted order, it will ignore the right part. That means the high value is modified to 4. Not even 4, it is modified to 4 minus 1, that is 3. So this is 3. So now this is our new high, this is low. So next what it will do? Then again the same process will get repeated. It will compute the mid value. Mid equal to low plus high by 2. So that is equivalent to, what is the mid value now? 0 plus 3 by 2. That is equivalent to 0 plus 3 by 2. That is 1. Since 3 divided by 2 is equivalent to quotient 1, we won't bother about the remainder. Now what is the value of a of 1? 6. Since the element is found, it will return the value 6 immediately. So that means how many operations we have performed? 2 operations. That means we have done the searching process for 2 operations. That means it's not order of 2, it is 2 operations. Now see, in case of x equal to 20, now what is our array? So 5, 6, 7, 8, 9, 10, 15, 20, 30. This is my array. 0, this is 8, this is 4. Now I am going to search for x equal to 20. So what is the low value? 0. And what is the high value? 8. Now I am finding the mid, which is equivalent to low plus high by 2. That is equivalent to 0 plus 8 by 2. 4. So the content of a of 4 is equal to 20. No, because it is 20, that is a of 4 is equivalent to 9. 9 is not equal to 20. But since it is in sorted order, so 20 is greater. So 20 is available at the right side only, not at the left side. So we can ignore the left part. Now see what is the value now. 20 has to be found. So in this case low value is modified to this position. Now this is my new low, that is equivalent to 5. So now low equal to 5, h equal to 8, mid is equivalent to 5 plus 8 by 2, that is 13 by 2, 6. So a of 6, what is the value of a of 6? So this is 5, 6, 7. So a of 6 is equivalent to 15. So now 15, that is equivalent to 15, which is not equal to 20. Fine, but 15 is less than 20. 20 is greater than 15. So this part will be ignored again in the second step. So this is the first step, this is the second step. Now low value is modified to this location. So now this is low, this is high. Now again we are repeating the process. Low equal to 7, high equal to 8, mid is equivalent to 7 plus 8 by 2, that is 15 by 2, which is equivalent to 7. Now what is the value of a of 7? That is 20. 20, which is equivalent to 20. Now how many operations we have taken here? 1, 2, 3. Now we can see first we are taking n elements here, then we are ignoring half of the elements. Here we are taking n by 2 elements, then here we are taking n by 4 elements. If next one is there, we will take n by 8 elements, and so on. We are taking the number of operations n by 2 power k elements in the last one element. When one element is there, the number, that means the remaining which is equivalent to n by 2 power k, that means kth iteration. So that means here n by 2 power 0, here n by 2 power 1, n by 2 power 2, this is n by 2 power 3, that means first iteration n by 0th iteration n by 2 power 0, first iteration n by 2 power 1, second iteration n by 2 power 2, this is n by 2 power 3. In last, that means if element is not found, one element will be remaining, that is n by 2 power k. Now see, if there is no element, that is if case is x equal to 4, x equal to 9 also we can see. X equal to 9 is simple. So if x equal to 9, then low equal to 0, high equal to 8, so mid is equivalent to 0 plus 8 by 2, that is equivalent to 4. A of 4 is equivalent to 9. So this is a one operation, only one operation or one iteration. Now take, so if there is no element here, if x equal to 4, my array is 5, 6, 7, 8, 9, 10, 15, 20, 30. Remember that the elements should be in sorted order. If there is no sorted order, you cannot apply the binary search algorithm. 0, 1, 2, 3, 4, 5, 6, 7, 8. Now the first set we are taking n values, that is n by 2 power 0, that means n by 2 power 0 values. Now So whenever n by 2 power 0, there are n elements. Fine. Now the case is low equal to 0, high equal to 8, mid is equivalent to low plus high by 2, that is 0 plus 8 by 2, which is equivalent to 4. A of 4 is equivalent to 9, which is not equivalent to x, that is 4. But 4 is less than 9. So we are ignoring right side part. Now this is my high. So that means what I am doing here, h equal to mid minus 1. Fine. So now that is h is equivalent to 4. 4 or 3, sorry, mid minus 1, since it is 3. So that means what, how many values? Initially 8 values are there. Now how many values we are taking? N by 2 values. Almost n by 2 values. That means in second iteration n by 2 power 1. So this is 0, our first, this second, okay, then there are n by 2 values almost. So now mid is equivalent to again low plus high by 2, which is equivalent to 0 plus 3 by 2, that is 1. Fine. A of 1 is equivalent to, what is the value of A of 1? 6. 6 is not equivalent to 4. But 4 is less than 6. Four is less than 6. Yeah. So we are ignoring this part. So now high is 0, low is 0. Fine. Now h equal to mid minus 1, that is equivalent to h equal to 0. So now mid value is equivalent to L plus h by 2, that is equivalent to 0 plus 0 by 2, that is 0. A of 0 value, what is the value of A of 0? Which is equivalent to 5, which is not equivalent to 4. Fine. Now we are, since 4 is less than 1, we are modifying the low to minus 1 or high to minus 1, sorry. H is equivalent to mid minus 1, that is equivalent to h equal to minus 1. But to perform the operation, low is greater than h. Whenever low is greater than h, terminate the process. That means element is not found. So in this case, how many elements are there? Almost n by 4 values. That is n by 2 power 2. In third case. So I'm 1, 2, 3, third case n by 2. So that means here we found 2 value, that means only one value, n by 4. So that means whenever we are going for n by 2 power k, kth iteration, last iteration, n by 2 power k, then there will be only one element. So n by 2 power k, we have only one element, that is n is equivalent to 2 power k, where k value is equivalent to log n base 2, which is equivalent to LGN. So that means the time complexity for finding the, whenever it is one iteration or for finding the k operations is LGN. That means which is equivalent to order of LGN. So this is the time complexity of binary search. If it is found at the first iteration, it will be 1, Otherwise, in average case it is order of LGN, or average case as well as worst case also. That means if element is found or if element is not found, then it is equivalent to order of LGN. This LGN is in logarithm with base 2. In computer science field, for majority of the log with base 2 values, so they have given the specific term called as LGN. Now see, the time complexity for linear search is order of n. The time complexity for binary search is order of LGN, but are order of log 2, so log n base 2. But the problem with binary search is the elements should be in sorted order. So what is the algorithm that I am writing? So read array and read key. So while then we are initializing low equal to 0, high equal to n minus 1, while, so when till when we are repeating the process, low is less than high or less than or equal to high. Then what we are doing, we are finding the mid value. Mid is equivalent to low plus high by 2. That means the same procedure what I had written I am explaining here. And if E of mid is equivalent to given x, then there is no issue, break. Then else, we have two cases. Else if A of mid is greater than x, greater than or equal to x, anything that you can consider. Else if A of mid is greater than x, that means x is smaller, it will be available in the left side, so high value will be mid minus 1. Else high value low value will be mid plus 1. If you understand the algorithm the procedure completely, it is very easy to write this algorithm. Finally, what you are doing, if low is less than mid, or we can see what we can say is flag equal to 1, break. Our element is found at this position, break. Or finally, if low is greater than high, what we can say, element is not found. A simple algorithm. Now I am writing the same algorithm here. So I am writing the same program in C language, you can see, so that you will understand the process of complete binary search. So what we are doing here, so I am including header file stdio.h, and I am defining max as some 200. So int main. So now I am declaring an array with max. Now I am declaring n as well as searching element x and pointer I, and I need two variables, low, mid and high. So printf enter n value or size of an array, scanf %d ampersand n. So printf \n enter array values for I equal to 0, I less than n, I plus plus. So scanf %d ampersand a of I. Now printf enter element to search, scanf %d ampersand x. So low equal to 0, high equal to n minus 1 if while low less than or equal to high, if sorry I have to find the mid value, mid is equivalent to low plus high by 2. So if a of mid is equivalent to x, then printf backslash n element found at percentage d position mid plus 1 break, because if element is found there is no need to repeat the loop, else if x is less than a of mid, so I'm not writing this braces since it is one statement. I can write here. So what I can do, x is less than means like left side high equal to mid minus 1, else low equal to mid plus 1. If finally low is greater than high, then printf backslash n element is not found. So I'm running this algorithm. Enter size of an array 9. Values are 5, 6, 7, 8, 9, 10, 15, 20, 30. I'm searching for 6 element is found at second position. Now I'm giving the same values. 5 and array values as 9. So 5, 6, 7, 8, 9, 10, 20, 15, 20, 30. And searching for the element 20, it is found at 8th position. Now last case there is no element, 9 and 5, 6, 7, 8, 9, 10, 15, 20, 30, and I am searching for the element 4. 4 is not found. So friends, what we had seen, but the problem with binary search is the element should be in sorted order. So to make the elements in sorted order, we need another algorithm, sorting algorithms. So in next video, I'll explain the time complexity analysis for the sorting algorithm called insertion sort. One kind of algorithm which is there, insertion sort. So in this video, I clearly explain the time complexity for linear search and binary search. Hope you enjoyed the video. So thank you for encouraging me. So please subscribe to the channel once before closing the window. So if it is not subscribed, and give your valuable comments in the comment box. Thank you for watching.